Good morning, all of you, once again. Now, we'll start with unit number 4. Unit 4 talks about testing of hypothesis. What is hypothesis? Characteristics of hypothesis, types of hypothesis, and different types of parametric as well as the non-parametric tests. So the content will include the brief introduction, meaning, characteristics, types of hypothesis, type 1 and type 2 error, steps in hypothesis testing, parametric test and non-parametric test, parametric test Z, T and chi-square, non-parametric test, rank correlation and ANOVA. So first we'll start with course objectives. The course objective of this particular unit is to understand the concept of hypothesis, its types and characteristics, to apply suitable hypothesis test in the field of study, understand the steps in testing of hypothesis, comprehend the test statistics. Now coming to the course outcomes, analyze hypothesis testing procedures with the help of parametric and non-parametric tests. Now, brief introduction. Major research objective of inferential statistics is testing of research hypothesis through statistical hypothesis. The hypothesis is tested based on the information obtained from a sample. Business use hypothesis test widely and industry uses them for decision making. So hypothesis tests are very important where researcher will test the assumption. Now, what is the meaning and definition of hypothesis? Hypothesis is an educated guess or proposed explanation for a phenomena which is based on some initial observation or data. It is a tentative assumption that can be tested and potentially proven or disproven through further investigation and experimentation. Hypothesis is often used in scientific research to guide the design of experiments and the collection and analysis of the data. So hypothesis is the tentative assumption, the validity of which remains to be tested. In other words, hypothesis is a guess or hunch. Some hypothesis examples include, if I water a plant daily, they will grow faster. So this is the hypothesis. Then the second example, adults can more accurately guess the temperature than the children. Butterfly prefer white flowers to orange ones. So these are some examples of hypothesis. So hypothesis is only a temporary assumption. It is a formal statement or a hunch work. Now we come to the characteristics of hypothesis. Hypothesis first characteristic is it should be clear, it should be precise, it should be reliable. So the hypothesis doesn't have conceptual clarity. If it is not concise, straightforward to the point, then it is not reliable at all. So hypothesis should be precise. Only then it is reliable. There is no need to write the lengthy statements or sentences in hypothesis. Then, if hypothesis is a relation hypothesis, then it should be stating the relationship between variables, the cause and effect relationship between variables. Third, hypothesis must be specific and should have a scope for conducting more tests. So hypothesis should be very clear, it should be very specific, and it should be self-explanatory. It should be amenable to testing within a reasonable time also. Hypothesis should be logical. The way of explanation of hypothesis must be very simple, and it should also be understood that simplicity of hypothesis is not related to its significance. So simplicity is something different. It is not associated with significance. So these are the characteristics of a good hypothesis. Now, what are the types of hypothesis? In research, there are two types of hypothesis, null and alternative. They work as a complementary pair, each stating that the other is wrong. Null hypothesis. This can be thought of as the implied hypothesis. Null means nothing. Like in Contract Act, we say a contract is null and void. This hypothesis states that there is no difference between groups or no relationship between variables. The null hypothesis is a presumption of a status quo or no change. There is no difference between variables. There is no relationship between the variables. Now, alternate hypothesis. Alternative hypothesis is being denoted by HA. This is also known as the claim. This hypothesis should state what you expect the data to show based on your research on the topic. This is your answer to your research question. So alternate is just opposite of the null hypothesis. Now we look at some example for conceptual clarity. Null hypothesis. There is no difference in the salary of factory workers based on the gender. So the salary of factory workers are same whether it's male or female. Alternative hypothesis, male factory workers have a higher salary than female factory workers. Now coming to the next example, null hypothesis, there is no relationship between height and shoe size. In alternate hypothesis, there is a positive relationship between height and shoe size. So these are types of hypothesis and the examples. Now we talk about type 1 and type 2 error. A type 1 error occurs if an investigator rejects a null hypothesis that is actually true in the population. So if an investigator or a researcher rejects HO, which is exactly true, it is called type 1 error. Type 2 error is also called as false negative error. It occurs if the investigator fails to reject a null hypothesis that is actually false in the population. So type 2 error takes place if you reject the null hypothesis that is actually false. Now, what are the steps in hypothesis testing procedure? Because this is we can say the basic foundation for solving any numerical, whether it is related to parametric test or it is related to the non-parametric test. So first, set up hypothesis. First, you have to set up the hypothesis properly. You have to make the proper assumptions. Then you have to set up a suitable significance level also, whether it is 5% level of significance. If it is 5% level of significance, then your confidence level will be 95%. If your confidence level is 90%, then your significance level will be 10%. Now, third step, determine suitable test statistic. You have to decide which test is suitable in this situation. Z test, T test, which we will discuss further. Fourth, then you have to determine the critical area or the critical region. Perform computations, calculated value, table value are compared and take a decision. If table value is greater than calculated value, HO will be accepted. And table value is less than calculated value, HO will be rejected. So these 6 steps are there in hypothesis test. Now, parametric test and non-parametric test. These are the two types of tests. Parametric tests are those that make assumptions about the parameters of the population distribution from which the sample is drawn. This is often the assumption that population data are normally distributed. So parametric test is based on assumption that population has a uniform distribution. It has a normal distribution. Non-parametric tests are distribution-free tests. They can be used for non-normal variables. They do not follow any normal bell-shaped curve. They do not follow any normal distribution curve. Parametric tests include z-test, t-test, and chi-square test, which we will study today. Non-parametric tests include rank correlation and ANOVA. ANOVA stands for analysis of variance. Now, in the same way, we should know what is a one-tailed test and what is a two-tailed test. One-tailed test results from an alternative hypothesis which specifies a single direction. When the alternative hypothesis states that parameter is in fact either bigger or smaller than the value specified in the null hypothesis. So where the inclination of the curve is towards only one side. Now, two-tailed test. Two-tailed test results from alternative hypotheses which do not specify the direction. When the alternative hypothesis states that null hypothesis is wrong. So two-tailed test where the inclination of the curve is on both the sides. Now, we first talk about the parametric test, first category, which is a z-test. Z-test is a statistical test to determine whether two population means are different when variances are known and sample is large. Z-test is hypothesis test in which Z statistics follows a normal distribution. Z statistics or Z score is a number representing the result from the Z-test. So Z-test is used when your sample size is greater than or equal to 30 and you know the variance of the universe or the population. So it is an important test. Now we look at the formula for Z-test. Z is equal to x bar minus mu upon standard deviation upon under root n. Here, x bar is mean of sample, mu is mean of population, sigma is the standard deviation of the population, and the square of standard deviation is called as a variance. N is the sample size or number of items. Now, we'll take one example of Z-test. Sorry. Okay, there is a professor who claimed that what is the average IQ of the people. So randomly a test was conducted on 30 students. So as I already mentioned you that Z-test is used when sample size is greater than or equal to 30. So a test was conducted on 30 students resulting in a mean IQ of 117. The population mean of entire freshman batch was 100 and the standard deviation was 27. One must identify the null and alternate hypothesis to check if the professor claim is true. Null hypothesis mu is equal to 100, mu is the population mean. So first we have to make HO. HA is alternative hypothesis, mu is greater than 100. So this is alternate hypothesis because professor want to test. Now we'll use the Z formula. We'll put the value together. Z is equal to x bar minus mu upon standard deviation upon under root n. So we have the calculated value of Z as 3.44. So 3.44 is the calculated value. Now if the table value of Z is 1.96 at 95% confidence level, so we can say that HO will be rejected because table value is very less, calculated value is high. So after comparing significance level with the Z score, the analyst either accepts or rejects the null hypothesis. So this is the example of Z test. Now coming to the t-test. A t-test is the second category of parametric test. It's a statistical test that is used to compare the means of two groups. It is often used in hypothesis testing to determine whether a process or treatment actually has an effect on the population of interest or whether two groups are different from one another. So a t-test is a small sample test. It is used when sample size is below 30 and you do not know the standard deviation or variance of the population. So first we'll look the t-test formula. The two formulas are there. First is of a one sample t-test. Second is of a two sample t-test. Sorry. T is equal to x bar minus mu upon standard deviation of sample upon under root n. And where the two sets of samples are there, t is equal to x bar 1 minus x bar 2 divided by variance of first sample upon n1 plus variance of second sample upon n2. So this is their one sample t-test and two sample t-test formula. So t-test is used when sample size is below 30 and you do not have a standard deviation. You have to calculate it manually. Although SPSS has all these steps inbuilt in it. Now, t-test example. A company wants to improve its sales. The previous sales data indicated that average sale of 25 salesmen was 50 per transaction. After training, the recent data showed an average sale of $80 per transaction. If the standard deviation is $15, find the T score. Has the training provided improved the sale? So you can see the sample size is below 30. It is only 25. Now you have to tell whether the training has improved the sales or not. So you will use a t-test. So first you have to write HO, null hypothesis, mu, okay. Then you have to write HA, it is not equal to mean sale 80, mu will be 50, as 15 and 25. And you can calculate the T, calculated value 10. Now suppose if significance level of T is given in the question as 5%. So the table value is 0.05. So 0.05 is there. So table value at 5% in T is 1.711, which is very less. And calculated value is 10. So when calculated value is more than table value, in that case, the null hypothesis will be rejected and we conclude that the training imparted has boosted or improved the sales. So alternate hypothesis will be accepted. Now here we have to remember that the table value is not constant in case of t-test. The table value of z is constant, which is not like the case in t-test. Now the third category of test is chi-square test. The third parametric test. A chi-square test is a statistical test used to compare observed results with expected result, observed frequency with expected frequency. The purpose of this test is to determine if a difference between observed data and expected data is due to chance or if it is due to a relationship between the variables you are studying. So chi-square test is developed by R.A. Fisher, the man who has given experimental design. Chi-square test is a test of independence, goodness of fit, and where you compare expected frequency with the actual or the observed frequency. Now, formula of chi-square test. So chi is a Greek letter word, delta. It is not chi, it is pronounced as chi. The formula is summation, observed value minus expected value, whole square upon expected value. So this is the formula to calculate the chi-square value. Then as usual, we compare it with table value. There is separate table given for the chi-square test. Now, example. Suppose we want to know if gender has anything to do with political party preference. So we poll 440 voters in a simple random sample to find out which political party they like. The result of survey are provided in the table below. So there are three parties: Republican, Democrat, and Independent. So we have to see the association between the gender to political party preference. So observed value to see if gender is linked to political party preference. So perform chi-square test to verify assumed theory. First, we define the cases for different hypotheses, such as HO. There is no link between gender and political party preference, means there is no relationship between the gender and political party. But HA or H 1, which is the alternate hypothesis, it says that there is a link between gender and political party preference. So first we have to make the HO and HA. Now we come to the solution. This is the observed value. To calculate expected value, we have to use formula. Expected value is equal to row total into column total divided by total number of observation. By this, we have an expected value. So the row total, verticals are columns, horizontal are rows. So this way we can calculate expected values. So it is 109. Now we can calculate expected value of other cells. So these are the expected values of other cells which we have calculated. So we have to make the row total, column total in the respective column, and then we have to write the expected value. Now we calculate the test statistics, which is the sum of cell values from the above table. So these are the expected frequencies calculation O minus E upon E. So the chi-square of calculated value is 9.837. Now coming to the table value. In chi-square, we see the number of rows and the columns. So row minus 1 into column minus 1. 3 are rows, columns are 2. So 3 minus 1 into 2 minus 1 is equal to 2. Where R is equal to number of column items, C is equal to number of row items. Now we can compare our obtained statistics with this. As we can see, for an alpha level of 0.05 and 2 degree of freedom. So if your significance level is 5%, so the chi-square table value is 5.991, which is less than calculated value. So we come to the conclusion that null hypothesis will be rejected. There is a link between the gender and political party preference. So we can say there is a connection between the gender, male, female, and their political party preference. Now, coming to non-parametric test. So we have studied the 3 parametric tests, Z test, T test, and chi-square. Now we come to non-parametric test. It's a non-parametric measure of rank correlation, statistical dependence between the ranking of 2 variables. It assesses how well the relationship between 2 variables can be described using a monotonic function. Spearman rank correlation coefficient is a non-parametric measure of correlation using ranks to calculate the correlation. So rank correlation is a non-parametric test. I'm not talking about Carl Pearson linear correlation. I'm talking about Spearman rank correlation. So we can take the example. As an example, let us consider a musical talent contest where 10 competitors are evaluated by 2 judges A and B. Usually, judges award numerical scores for each contestant after his or her performance. A product moment correlation coefficient of scores by the 2 judges hardly makes sense here, as we are not interested in examining the existence or otherwise of a linear relationship between the scores. What makes more sense is correlation is between ranks of contestants as judged by the 2 judges. So we have to see whether their thinking pattern matches or not, or it does not matches. Now, this is the formula for n correlation. 1 minus 6 summation d square I upon n into n square minus 1 bracket close. N is the number of items, number of sample size, and d is the difference of rank R1 minus R2. And the Spearman rank correlation coefficient ranges from -1 to +1. Now, how to interpret a statistically significant Spearman rank correlation? It is important to realize that statistical significance does not indicate the strength of Spearman correlation. In fact, the statistical significance testing of Spearman correlation does not provide you with any information about the strength of the relationship. Thus, achieving a value of P is equal to 0.001, for example, does not mean that relationship is stronger than if you achieve a value of p is equal to 0.04. This is because the significance test is investigating whether you can reject or fail to reject the null hypothesis. So this is about Spearman rank correlation. It is a non-parametric test, which is distribution free test. Now we come to ANOVA. ANOVA is the father of all the tests given by Professor R.A. Fisher. ANOVA stands for analysis of variance. It's a statistical method used to analyze the differences between the means of two or more groups or treatments. It is often used to determine whether there are any statistically significant differences between the means of different groups or not. So we just see the ANOVA first. One-way ANOVA. One-way ANOVA is used to compare two means from two independent unrelated groups using F distribution. The null hypothesis for the test is that the two means are equal. Therefore, a significant result means that the two means are unequal. Examples of when to use a one-way ANOVA. Situation 1. You have a group of individuals randomly split into smaller groups and completing different tasks. For example, you might be studying the effects of tea on weight loss and form three groups: green tea, black tea, and no tea. Now we have second situation. But in this case, individuals are split into groups based on an attribute they possess. For example, you might be studying leg strength of people according to weight. You could split participants into weight categories who are obese, overweight, and normal, and measure their leg strength on a weight machine. So these are the situations or examples where you can use ANOVA or analysis of the variance. Now, two-way ANOVA. A two-way ANOVA is extension of the one-way ANOVA. With a one-way, you have one independent variable affecting a dependent variable. With a two-way ANOVA, there are two independent variables. Use a two-way ANOVA when you have one measurement variable, that is a quantitative variable, and two nominal variables. In other words, if your experiment has a quantitative outcome or you have two categorical explanatory variables, a two-way ANOVA is appropriate. For example, you might want to find out if there is an interaction between income and gender for anxiety level at job interview. The anxiety level is the outcome or the variable that can be measured. Gender and income are the two categorical variables. So these categorical variables are called independent variables, which are called factors in a two-way ANOVA. So this is the example of two-way ANOVA. Now, these are the these are the terms or formula which is used in ANOVA. Source of variation. There are two sources within sample, between sample. Sum of squares. Degree of freedom, which is n minus 1. Mean square. Mean square is equal to SS upon DF, sum of square upon DF. Now we have to apply F test for ANOVA. F ratio is equal to mean square based on between sample variance upon mean square based on within sample variance. So this is the formula for ANOVA. ANOVA uses F distribution. We do not have separate formula for ANOVA. In ANOVA, we use F, and all these terminologies are used in ANOVA. Now, coming to the conclusion part. So we have studied parametric tests and non-parametric tests. Major research objective of inferential statistics is testing of research hypothesis through statistical hypothesis. Following the sample approach, a hypothesis is accepted or rejected on the basis of sampling information alone. A test is called one-tailed only if the null hypothesis gets rejected. When the value of test statistics falls in acceptance region of the distribution. The acceptance and rejection of hypothesis depends upon similar result. There are various parametric tests like Z, T, and chi-square, and non-parametric tests like ANOVA and rank correlation, which must be used appropriately in the research. So hypothesis testing is the critical part. Hypothesis is the assumption whose validity we have to test through use of parametric and non-parametric tests. But at the same time, we should understand where to use which kind of test. Although we have SPSS software, a statistical package for social sciences, but still, we should know the suitable conditions where you will use hypothesis test. Hypothesis should be simple, easy to understand, concise. We should see the what is the procedure for testing hypothesis, when to accept HO, when to reject HO, what is the table value, what is confidence interval. All these terminologies are very important in testing of hypothesis. Now, these are certain reference books and NPTEL video lecture links. The two are the books which are mentioned here. It is Polytech FH, Hypothesis Testing Behavior, United Kingdom, Taylor and Francis. Second is the Privatida GJ 2011, Statistics for Behavioral Sciences, India says publication. And the two are the video lecture links of NPTEL video lectures. So you can watch this video, which are being on the YouTube also, which are given by Swayam MOOC courses by NPTEL. So with this unit 4 of research methodology, its course is completed from my side. And unit 4 is the only unit which is having lots of numerical tests in the form of Z, T, chi-square, ANOVA. Basically, there are different tests which we haven't covered here because as per syllabus, as per the course of research methodology, we have only 5 tests. There are similar other tests like F test, Mann-Whitney, U test, multiple discriminant analysis, factor analysis, which are used in advanced situation. But in context of BBA students, these tests are important. And these tests are basic tests, but we should use where to apply and demonstrate the test. There are so many tests and there is a thin line difference. Like if I talk about Z test, T test. So Z and T, although they look similar, but Z is a large sample test, which is used when sample is greater than or equal to 30. On the contrary, T is a small sample test. It is used for sample sizes below 30 and you do not have standard deviation also. So these are the tests which are used extensively in hypothesis. Hypothesis is only a tentative assumption. It is not permanent assumption. If it is a permanent assumption, it is not hypothesis, it is stereotyping or a rigid perception about particular person. So with this, I want to thank all the students. Okay, thank you so much. Thanks.